Chapter 9. Harnessing the lightning. What is lightning? People are often frightened by the terrific power that runs wild in a bolt of lightning. When it hits a building, it does fearful damage, and once in a great while it kills someone without a moment's warning. Yet the same power, when produced by man and properly harnessed and directed, is the most useful servant that man has today. It does many more things for him than steam can do. Not only does it run engines, it lights his home, it carries his voice across continents and oceans, and it even brings him wonderful music from far away. We call this great power electricity. We know just what steam is. We know that it is simply water heated until it becomes a gas. Nobody knows what electricity is. It cannot be seen or handled or weighed. But man has learned to control it and to put it to work for him in many different ways. The ancient Greeks 2,500 years ago noticed the strange fact that a piece of amber or of certain other substances, when rubbed briskly, caused tiny bits of light material, such as cloth, if held near, to jump to it and cling there. But nobody had any idea that the mysterious power that made the bit of cloth jump to the amber was the same as that which threw the mighty lightning bolts across the sky. Who coined the word electricity? It was not until the 17th century, about 300 years ago, that men tried to learn more about electricity by actual experiment. An Englishman, Sir Thomas Browne, coined the word electricity. We first find it in a book that he published in 1646. In the 18th century, real progress began to be made. It was found that some objects will give off electricity while others will not. Also that electricity can be passed from one object to another. What was a Leyden jar? About 1745, a strange kind of bottle called the Leyden jar aroused a great deal of interest among people in Europe and in America. A man named Cuneus, while visiting a friend's laboratory in the city of Leyden in Holland, happened to pick up a bottle of water in which an electrically charged wire was dipping, and with his other hand touched the wire. He got a violent shock. Later, it was found that the same effect could be brought about by using an empty bottle coated with tinfoil on both the outside and the inside, and then charged with electricity. The Leyden jar attracted the attention of Benjamin Franklin, one of the greatest Americans that ever lived. He studied the problem and showed just how the shock was caused. By connecting a number of Leyden jars one to another, he was able to produce a shock of such great force that it nearly killed him. Now, a number of men began to think that perhaps the force that nearly knocked them down when they took hold of a Leyden jar might be the same as lightning. What was Franklin's experiment? At last the day for the great experiment arrived. During a thunderstorm, Franklin and his young son, standing under a shed, sent a large kite up into the clouds. To the end of the long cord holding the kite, he had attached a metal key. Franklin held the cord by a silk ribbon, silk being what is called a non-conductor. That is, electricity does not pass through it. As the lightning flashed up in the sky, Franklin noticed that the fibers of the cord began to bristle like a cat's fur. He cautiously touched his knuckles to the key. Presto! A spark jumped from the key into his hand. Filled with excitement, he brought together the key and the Leyden jar. The Leyden jar was immediately electrified and acted in the same way as when it was charged with electricity produced by rubbing. What a beautiful experiment it was. A direct result of Franklin's experiment was the invention of the lightning rod, which farmers put up on the roofs of their houses and barns. These tall rods act as protection against lightning bolts. Who invented the first battery? We may say that electricity, as a great servant of mankind, really was born in 1800, when an Italian named Volta invented the first electric storage battery, producing a continuous current of electricity. The battery consisted of a pile of metal discs, first one of copper and then one of zinc, with a piece of cloth moistened in acid between them. The electric battery created great excitement. The next great step in harnessing electricity was made by a Dane named Ørsted. While experimenting with a compass needle and a wire charged with electricity, he noticed some unusual effects. The needle behaved very strangely. He saw that there was a close relationship between magnetism and electricity. In 1820, he announced to the world his great discovery. This discovery led to the invention of the electromagnet. This was one of the most amazing inventions ever made by man. The electromagnet consisted of an iron magnet with a wire wound around it. By winding the wire in a certain way, the magnet was made to spin around as long as the current lasted. Who invented the electromagnet? It was on Christmas Day in the year 1821 that a young Englishman named Michael Faraday put into operation his electromagnet. Faraday was the son of a blacksmith and had started out in life as a London newsboy. He educated himself and became an assistant in the laboratory of the great scientist, Sir Humphrey Davy. The story of his life and work reads like a wonderful fairy tale. Thus was electricity harnessed so that it was made to do actual work. Electric motors of greater and greater power were developed for running all sorts of engines, operating streetcars and the like. An electric motor is much the same as an electric dynamo. What is a dynamo? A dynamo is a machine for producing electric current, while the motor is a machine that receives a current and produces mechanical power. The wire coils are wound somewhat differently. We now come to another wonderful invention. A wire was wound around a small iron bar, and whenever an electric current was sent through the wire, the bar became magnetized. By turning the current on and then off, the bar would attract and then release another little piece of iron placed near it, making a clicking sound as it did so. In this way, it was possible to send signals over a wire for long distances. A man sitting at one end of the wire would work a little key up and down, turning the current on and then off, and the instrument at the other end of the line would respond. Who built the first telegraph? It was an American, Samuel F.B. Morse, who built the first telegraph line. It was 3 miles long. By combining short and long clicks, called dots and dashes, he was able to make a different signal for each letter of the alphabet. His experiment was so successful that Congress gave him the sum of $30,000 with which to construct a telegraph line from Baltimore, Maryland to Washington, D.C. And in 1844, the first telegram was sent over the wire from one city to another. Then people began to wonder if a telegraph line could not be laid under the ocean to connect America and Europe. That was a daring idea. Think of it, a wire 3,000 miles long resting on the bottom of the ocean. Furthermore, the wire would have to be placed in a thick rubber covering to keep the electricity from escaping into the water. A man named Cyrus W. Field worked for many years at great expense in an attempt to lay such a cable between the two continents. In the year 1858, he succeeded in making the connection, but the cable broke. Then, the Civil War came along, and operations had to be stopped. But after the war, Mr. Field went ahead again, and in 1866, the United States and England began talking with each other across the ocean. Who invented the telephone? If messages could be sent at lightning speed over telegraph wires, might it not be possible to send the human voice itself over the wires? That was the most daring idea that had occurred to any inventor up to that time. Probably no inventor ever faced more discouragement and ridicule than did Alexander Graham Bell, the inventor of the telephone. People thought he was crazy. Even after success was in his grasp, he was laughed at as a crank who says he can talk through a wire. Mr. Bell was not even a scientist. He was a teacher in a school for deaf and dumb children. But this work had led him to make a careful study of the human ear to find out how it carried sounds to the brain, for it is in the brain that we hear sounds. What he discovered made him feel sure that the telephone was a possibility. How does the telephone work? He set to work to make an artificial eardrum out of a thin disc of metal. By talking upon this disc, he made it vibrate a piece of iron connected with an electromagnet. Then he connected, with a long piece of wire, this electromagnet with another to which was attached a similar disc. One was the transmitter and the other the receiver. When he talked into the transmitter, the vibrations of the disc made changes in the electric current. And as the current reached the other end, it made the disc at that end vibrate in the same way as the first disc. And when these vibrations struck the eardrum of the person holding the receiver, he heard sounds, the sounds made by the person talking at the other end of the wire. This sounds very simple as we tell about it now. But it was only after long and patient experimenting that success crowned Bell's efforts. At the Great Exposition held in Philadelphia to celebrate the 100th anniversary of the Declaration of Independence, Bell gave a public demonstration of the telephone. Today, there are millions in use throughout this and other countries. Who discovered wireless? But greater wonders were still in store. It was known that electricity sends waves out into space that travel with the speed of light. A man named Heinrich Hertz in Germany invented an eye that would catch these waves, but it was a young Italian, Guglielmo Marconi, who made the wonderful instruments with which messages could be sent through the air without wires over great distances. The latest result of harnessing the lightning is the wonderful radio that fills our homes with music and enables the president sitting in the White House to talk to the whole nation. Who made the first audion tubes? The radio is simply a wireless telephone. The transmitter is the microphone. The receiver is a little glass bulb called the audion. Inside of it, there is a vacuum and a metal filament which is made to glow by the current from a small electric battery. The audion was invented by a young American, Lee DeForest, who, after finishing a course in electrical research at Yale University, went to work for the Western Electric Company in Chicago, and at night, in his room, carried on experiments with the mysterious electric waves. Meanwhile, the electricity had been harnessed to do another beneficial job for man. It was made to light his homes and schools, his stores and factories, and other buildings, and his public streets. This first electric light was the arc light. Two sticks of carbon were set close together, and an electric current was forced to leap from one to the other, the resistance of the air making the carbons glow. But the light was too intense and glaring for ordinary use indoors, though fairly satisfactory outdoors. Who invented the incandescent light? Thomas A. Edison, one of the world's greatest inventors, succeeded, after many years of hard work, in making an electric light that would serve all common purposes. At last, he gave to the world the incandescent lamp. It was almost by accident that he hit upon the solution of the problem. He sealed a thread of carbon into a glass bulb from which the air had been pumped out. Then he turned on the electric current. The carbon gave off a beautiful, soft light. The electric current could be made to light many of his lamps. It could be divided into as small units as were desired. This was not the case with the arc lamp. The first commercial electric lighting plant was installed on the steamship Columbia in May 1880. Great improvements, of course, have been made in the electric light since then. There are lamps of all sizes and degrees of brightness. What a dreary world this would be without the electric light.